The other major theme in moving straight ahead is solving linear relationships. And we talked about the equality, the property of equality. In other words, adding or subtracting, dividing, or multiplying one thing to an equal sign is okay as long as you do the exact same thing to the other side. So, how did that show up in practice? So if we have 12 minus 5x is equal to 7x, this is the Framkels. We needed to have all the variables on one side of the equal sign. Well, what's the opposite of negative 5x? Positive 5x. Now, you can't add 5x to one side of an equal sign if you don't do it to the other side. 7x plus 5x is 12x. 12 gets brought down, and negative 5x plus 5x is 0. We really wanted to zero this out, cancel it out in other words. And so we have our equal sign inside the fence, the Framkels, or whatever you want to call them. And so the next step is to divide, to see what is the opposite of multiplying 12 to x. The opposite of multiplying 12 to x is dividing 12 to. What you do to one side, you have to do to the other, so 1 is equal to x. So that is question A. Question B. So I'm going to rewrite the problem because I need more space. Same thing goes here. We want to get all of the x's on one side of the equal sign, and we remember that we cannot add or subtract things that are not similar. In other words, we can only add x's to x's and things without x's to other things without x's. So the opposite of positive 2x is negative 2x. So I'm going to subtract 2x from both sides. What I do to one side, I have to do to the other. 2x minus 2x is 0. They cancel out. So we have negative 3 is equal to 3x, because if I have 5 x's and I take 2 of the x's away, just for those people who are having troubles with it, so if I have 5 x's and I take 2 x's away, what do I have left? I have 3 x's. So you have to keep the x in the expression. This gets brought down, plus 12. So what is the opposite of adding 12 to x? Subtracting 12 to x. And again, the object of this exercise is to get the x all by itself so we know what it's equal to. So we're sort of undoing the equation. We're working backwards from please excuse my dear Aunt Sally. Negative 3 minus 12 is negative 15 is equal to 3x. What's the opposite of multiplying x by 3? Dividing by 3, divided by 3. And we know that negative 15 divided by 3 is negative 5. So x equals negative 5. C. I'm just going to repeat this over and over again. So we have 2x plus 25 is equal to 7x. Same pattern. What's the opposite of 2x? Negative 2x. So we get 25 is equal to 5x. What's the opposite of multiplying x by 5? Dividing by 5. Divided by 5. So we have 5 is equal to x. Now finally, D is the only one that's marginally different. There are a couple ways you could do it, and I'll do it both ways. So that's one way that I'm going to do it. Obviously, you're probably just going to only do it one way, but I will show you both. So in this case, I can distribute the 3. In other words, what is outside the parentheses, when it's right next to it, means that we're multiplying everything inside the parentheses by what's on the outside of the parentheses. In this case, 3. So we end up with 3x plus 3, because 3 times x is 3x, 3 times 1 is 3, so equal to 12. Minus 3, minus 3. So we get 3x is equal to 9. The opposite of multiplying x by 3 is dividing. Divide. So I get x is equal to 3. On the other side, this is what I could do. It's going to be a little bit quicker. I'm just going to divide everything by 3. 3 divided by 3 is 1. 12 divided by 3 is 4. So I get x plus 1 is 4, minus 1, minus 1. So I get x is equal to 3. Either way, you get the same answer. a student who's studying walking rates, because walking rates really are interesting to study, enters the rule y equals 40 plus 2x into the calculator and produces this graph. He has highlighted one point on the graph, in this case, this one right here. And the calculator says the x is 88 and the y is 216. What question would the student be trying to answer by using the graph? Well, the thing is, we don't know if we're talking kilometers or miles, so I'm going to pick a distance. So I'm guessing if this student walked 88, that's really far, folks. How much would they earn? The flip of that is if a student earned $216, how far did they walk? That would also be acceptable. Now the question is, how did I know this? Well, I know if we're talking about walking rates. Oh my goodness gracious. I'm talking about something completely different. I'm talking about a walkathon. My bad. So if we're talking about walking rates, when I was thinking rates, I was thinking rate as an income. This is speed, right? So if we're talking about the actual walking rates, so we're going to have time, because we know that rate times time equals distance, right? And we remember that from comparing and scaling. So my time and my distance are going to have to be here, right? So 88 is a time. That is a distance. So I guess the student is wondering, if I walk for 88 minutes, that's just far more realistic. How far would I go? Now the thing that's sort of interesting is, if we're talking about walking rates, what does this 40 mean? And I know that's not part of the question, but that 40 means that you started 40, whatever your distance is, 40 miles, or probably not miles, how about 40 feet from your starting point. Write the question for part A as an equation that could be used to solve the answer. So we know the equation is y is equal to 40 plus 2x. And I'm just using what was in the problem. And so we want to go 88 minutes, right? And x is going to be minutes, because that is the independent variable. So y is equal to 40 plus 2 times 88. Well, 2 times 88 is 2 times 8 is 16, carry the 1. So that's 16, all right. So you add those together and you get 216. So there you have it. I believe that is the last page, just double checking here. But it is not. To encourage customers, a new movie theater is offering membership. We love membership. And we are going to have to graph this. So I'm going to do this next one on a separate grid, on a separate video rather.